Taking mixtures apart. You made a mixture of gravel and water in class. You put 50 milliliters of water and a spoonful of gravel in a cup, and the job was done. Then you separated the mixture of gravel and water. You poured the mixture through a screen. The gravel stayed on the screen and the water passed through. All mixtures can be separated, but not all mixtures can be separated in the same way. The physical properties of the materials in the mixture can be used to separate the mixture. Particle size is a physical property of gravel. Particle size is a physical property of water. The particles of gravel are larger than holes in the screen. The particles of water are smaller than the holes in the screen. The screen can be used to separate the mixture. In class, the mixture of diatomaceous earth and water passed through the screen. The particles of the powder and water are both smaller than the holes in the screen. What properties will separate powder from water? The answer is size again. Powder particles are larger than the holes in filter paper. Water particles are smaller. Filter paper will separate a mixture of powder and water. Other ways to separate mixtures. Imagine you open a drawer to get a rubber band. Oops, the rubber bands spill. So does a box of toothpicks and some nails. The drawer has an accidental mixture of nails, toothpicks, and rubber bands. How can you separate the mixture? You can use the properties of shape. You can pick out each piece one at a time, but it might take 10 minutes to separate the mixture. Nails are made of steel. Steel has a useful property. Steel sticks to magnets. If you have a magnet, you can separate the steel nails from the mixture in a few seconds. Magnetism is a property that can help separate mixtures. A mixture of nails, toothpicks, and rubber bands. What about the toothpicks and rubber bands? Wood floats in water. Rubber sinks in water. The property of density, sinking and floating, can be used to separate the wood, toothpicks, and rubber bands. Dropping the mixture into a cup of water, then scoop up the toothpicks from the surface of the water. Pour the water and rubber bands through a screen. The water will pass through the screen, but the rubber bands won't. Now, the job is done. Magnetism is a property that helps separate mixtures. Density is a property that helps separate mixtures. Separating solutions. A mixture of salt and water is a solution. The dissolved salt particles and the water particles are both smaller than the holes in filter paper. The property of size is not useful for separating a solution of salt and water, but evaporation will work. Evaporation is the change of state from liquid to gas. Water evaporates, but salt does not. When a salt solution is left in an open container, the water slowly turns to gas and goes into the air. The salt is left behind. Solutions can be separated by evaporating the liquid. The salt left behind after evaporation doesn't look like the salt that dissolved in the water. Is it still salt? Yes, it is. When the water evaporates, the salt reappears as salt crystals. Salt crystals always look square. Salt crystals also often have lines going from corner to corner, forming an X. Many solid materials dissolve in water to make solutions. When the water evaporates, the materials reappear as crystals. Each different material has its own crystal shape. Some crystals are needle sharp, other crystals are stick-sided. Others are like tiny fans. Crystal shape is a physical property. Crystal shape can be used to identify materials. Whenever you observe square-shaped crystals in an evaporation dish, you will know that salt might be one of the ingredients in the solution. Here's 3 different crystal forms. Conservation of matter. There's one more thing to think about when you make a mixture. All matter has mass. Anything that has mass is matter. If you have 200 milliliters of water in a cup and add 30 grams of sand to the cup of water, what will the mass of the mixture be? The mass of 200 milliliters of water is 200 grams. So the mass of the mixture will be 200 grams of water plus 30 grams of sand, which is 230 grams for the mixture. That seems pretty easy to understand. But a mixture of salt and water is a little trickier to think about. When you mix 30 grams of salt with 200 grams of water, what do you think the mass of the mixture will be? The salt disappears in the water, so what happens to its mass? Did you conduct the investigation? The mass of the clear solution is 230 grams. That is the sum of the mass of the water and the mass of the salt. The mass of a substance like salt does not change when it dissolves. Even if you can't see it, the salt is still there, and its mass has not changed. In fact, mass never goes away. Mass is conserved. Therefore, matter is conserved. That means matter can change shape, state, or location, but it can never be lost or destroyed.